Hey, remember when gas lighting gave way to electricity as the future for lighting? Yeah, me neither, because it was over 100 years ago. Well, the times are changing again, and lighting is only part of the story. Hey guys, welcome. My name is Rob Boyd, and you're watching TechWise TV. You know, incandescent light bulbs still produce light the same way they did since the 1860s. A coil of wire inside this vacuum-tight glass enclosure agitates electrons through that coil by applying the proper voltage so that it gets white hot. So hot that it produces light. So the more resistance, the brighter the light. Well, Edison is credited with making the light bulb practical, but what is often overlooked is that moving from gas lights to electric lights, well, it required electricity. Well, this was a distribution challenge that Edison and his team took on as they designed all the components needed to get direct current to the light bulb. The sockets, the fuses, the switches, the power meters, the generators, the wiring. Well, the Edison Electric Illuminating Company, formed in 1882, brought electric light to parts of New York by creating a network. Cables that were insulated with beeswax and paraffin will run underneath the streets, but then problems came up. Horses were shocked trotting down wet streets. Workmen were electrocuted. Well, it was 43 years before electricity finally began to surpass gas as the lighting network of choice for the United States. And the light bulbs have finally started evolving from incandescent to fluorescent and, of course, LEDs, but the infrastructure has remained the same. And what's fascinating here is that it was actually not Edison's network that brought electricity to the masses. It was a different genius that made this possible. We're going to show you how lighting, heating, ventilation, air conditioning, security, and many other siloed networks found in every building today are coming together for huge benefits within Cisco's digital ceiling. We'll start with one of Cisco's innovators in this space, John Beckelmans. None of us were around in the early 1900s when the great transition from gas to electricity brought incredibly positive change to just about everything. But we're all here for that next big transition, made possible by the innovation and the convergence of both lighting and networking technology.
Historically, people will see and remember this as the first time core capabilities inside of a building became IP-enabled.
John Beckelmans, Chief Technology Officer for Cisco, is focused on creating digital ceilings inside commercial buildings of all sizes and uses. Well, these digital ceilings will enable organizations to converge previously disparate networks such as light, heating, cooling, security, and even more by moving core building functions onto the data network, starting with lighting.
That light point and the IP enablement of the light point has now new capabilities for data, for experiences, and for all the other things you can imagine.
There is a lot happening for lighting, but remember, it is only a starting point for something much bigger.
Once you have a networked luminaire and you have capabilities to actually put sensors in that same luminaire, now all your data comes together in that luminaire, and not just in that one luminaire, across your entire ceiling.
Cooling, lighting, and ventilation account for 62% of electricity use in commercial buildings. Well, today, each of these systems is an island of things that have to be managed separately. Innovations with power over Ethernet allow us to now both power and manage every light from the IT network. So now we have an entirely new foundation for controlling costs, for driving productivity, for delivering new user experiences.
Now you have a number of sensing slots, like a temperature sensor, a humidity sensor, a presence sensor, over time a camera, which is also a sensor. And it's the combination of those sensors into those luminaires which makes it a very interesting play, because it's not just about lighting. It starts with lighting, but because the sensors are integrated into the luminaires, now you get a whole new data flow inside of your ceiling.
As big as this is, it's a familiar Cisco model. Lights are now part of a centralized, intelligent network. Just connect those lights using an open information model together with a building automation system from companies like Johnson Controls, and now previously disconnected networks are communicating, and each device can be controlled from just one place in really granular ways. It's the power of the digital ceiling.
We know how to deal with convergence. We've shown that a number of times already, and we're able now to use that network and the network power to make smart decisions about your buildings and make your buildings more intelligent.
The lights are smart. Well, they now connect to other building networks in the digital ceiling, and we've shown that this can have a huge impact on productivity. But that's still not all.
In retail environments, where lighting plays such an important role, think about a shop, think about color tuning lights, think about guiding people to particular areas of the shop based upon their profile, based upon recognizing them via a smartphone app.
Office environments that adjust their use of electricity based on ambient light, temperature, and actual occupancy or activity in a specific area. We are at that tipping point, and the future looks bright.
LED lights become more efficient and become cheaper. There is a natural drive to, of course, save more energy. There is a natural drive to do more convergence over the network and to increase the role of the network. And the network becomes the center of not just power, but also control of your entire, what we call, digital ceiling.
Well, Louis, thank you so much for not only just showing up, because first of all, I appreciate when any guest will actually show up, but you brought more than enough toys. This is more than 1 or 2 trips from your lab. You used a cart to bring everything in. But first, define for me what it is, because I want to get specific here. What is it in your mind, or in the way you've been working with our customers on this, what is it we're doing differently here?
What we're doing is that technology is really getting to the point where it's affecting all sorts of building infrastructure. So you're seeing all these devices require 2 things. They require power and control, and the network is going to provide that.
Okay.
So we're going to start off, here's a pneumatic valve for HVAC control, and we have network that the network actually powers and controls the lights, or
Interesting.
the HVAC.
So that's something you'd only see in a commercial building, because you're talking about moving airflow around. Now, it looks like most of what you have here, though, is lights. But as we were kind of talking about, this is not just about lighting. This is about lighting has reached a point where we can do some extremely valuable things. We can power them off the switch port because the power balance has gotten to the right point with LEDs and the ability to put the right kind of light in the right places. That's our starting point for getting into building intelligence. Is that correct?
That's exactly right. And it is about power and control.
Okay.
And because you do have a gig port, you're going to see that lighting over time was going to change and be more strategic beyond providing lights.
Well, give me an example of what makes lights different here, because these look like take this one right here. This looks like a fairly normal light, with the exception that I only see 1 cable coming to it, and it's plugged into a Cisco switch, so that's where your PoE, your power is coming to this, but you mentioned control as well, which you just did. Okay, so you can turn the light off and on and power it, and then just to be overly obvious,
That's right. And what's different,
that is all we've got on here.
What's different, as you'll note, is the driver that powers and controls lights. It's PoE powered, versus an AC powered driver that has a whole bunch of wires and takes a bunch of labor to install.
So I'm assuming that I can do this just fine, because this speaks to the fact that I can actually just unplug see how simple that is? I can just unplug, it's a standard cable,
right.
and there's no power that goes to that cable unless it's requested, because this is the same thing we've been doing with phones and cameras and wireless access points, right? I mean,
Absolutely.
This is, PoE is also a low voltage technology, because we're talking about driving this from the switch.
Yeah, there is a voltage transformation that occurs, and it is DC power. So imagine the impact to adds, moves, and changes where the electrician doesn't have to go turn off a circuit, add, or move a light.
Right.
So now it's all low voltage, it's all plug and play.
Which means that's less disruption to the rest of the building, potentially, that was sitting on that same dumb daisy chain circuit. Now we're talking about this, that one addressable unit gets unplugged, nothing happens, there's no current flowing through it, and it's not affecting anyone else just because that one light needed to be worked on, or one device.
Absolutely. And the other thing is that it's faster. So it's just a click of an RJ45 cable, and you have power and control to the lights.
Because that was a kind of a standard white LED. I notice you've got something here that looks like it's got some different colors. This is made by another one of our partners, New LEDs, and we work with a bunch of different partners, as I understand it. I'm going to turn it this way, because you've got the standard 1 cable in there. So we want to see the reflection of the light, right?
Yep, I'm going to go ahead and turn on this light. So right now it's set to white, but the beauty of it is multicolor. So, we can do red, we can do blue, we can do other colors. And that's actually the thing that's unique about this. It's not just about white light in buildings. Building designs are changing. You'll notice that there's a shift for open workspaces, collaboration, because it's about employee productivity.
Right.
And being able to provide an experience where the employee enjoys and is stimulated by the building is important. At the same time, facilities needs to be able to reconfigure spaces quickly to adapt to changing work environments.
a lot less wiring because you don't have that high voltage wiring going through there. And then the fixtures come in a lot of different sizes because it looks like
and styles.
The sizes and styles, it looks like the manufacturers are creating things. These are all LEDs. They're all run off PoE, but they look kind of like a normal light. But that's kind of the point, is that we can first start replacing lights or working with lights that are familiar to us from a form factor and architecture perspective. But really the sky's the limit in terms of your ability to put small or large lights. If you need a little light, a lot of light, you can put it anywhere because neither the cabling nor the light itself has to be particularly large or have heat issues for dissipation.
Absolutely. The next step of this evolution is now that we have a big data pipe, because you have a gig port going into each one of these lights. Right. And by the way, it's still more economical than the traditional way. So in the future, what you'll see is all sorts of creative technologies that are embedded into these lights. Think of having Bluetooth so that you can track movement of things under the light.
I'm getting excited about what else we have here, but yep, Bluetooth.
Absolutely. And think of emergency situations where the fire department might need to know how many people are still in the building.
So you can sense one thing and you can signal it with the lights to let you know that certain conditions are present in certain areas, or to assist with evacuations or assist with first responders. These are stuff we tend to think of first in the occupancy, measuring this stuff without the users even having to be aware or interact with it. And that's really driven by a lot of what you talk about here, because once it's data, then the sky's the limit on what we can do with it. These are sensors that measure certain things, I assume, or is that a light? What did I pick up there?
So this is an occupancy sensor.
Okay.
So you can detect motion and trigger lights.
Okay.
So there are energy efficiency standards that require sensors. Some lights have them already embedded into the light fixture itself. You also have the traditional physical controls that allow you to create scenes. So now you push a button and a scene is played out in a room.
But the point is this also puts users into a spot where they don't have to react any differently just because the system behind the walls is doing something. Everybody knows how to use a light switch, but now instead of it being a circuit interrupt like it would be in a normal situation with high voltage, it's an addressable device that is doing whatever we program those buttons to do. And as you've already demonstrated with the color control and then the sensor inputs, that could be any combination of things.
Absolutely.
Wow.
And at the same time, because you have the communications capability in all these devices, the facilities department is now going to be able to use that information to determine how buildings are used and be able to react and reconfigure spaces dynamically to respond to the user's needs.
Very, very interesting. I brought this picture up because we snuck this out of your lab, but it's kind of hard to tell from the picture, but this is coming down from the ceiling. It's a rack of equipment in the ceiling. So obviously we're talking about some changes to network engineers and the way we think of network design with something like this. Is that something we need to fear? We're now racking stuff in the ceiling. Describe to me what we're looking at here.
So basically there are two deployment models today. There's a centralized deployment model where you have switches in the wiring closet.
Okay.
Another way of doing this is a decentralized model where you will install switches in the ceiling space to provide shorter cabling distances. And I foresee that over time, you'll see hybrids. So you'll see more regional wiring closets and at the same time still have in-room switches, either ceiling or the wall.
The point is, though, obviously, is that things change. We tend to have to think of things in the way in which we are coming from. But then once we kind of get beyond those mental hurdles, and designers who we're really speaking to on this, because we're talking about a time when buildings go in before data network goes in. So we're really talking about a time where our typical audience for TechWise TV looks at this and goes, wow, I might be suddenly working in a building that's already got this, or I might be working now with a lighting architect or someone in the early stages of design to say, what is the best way for us to support this? Because that's the most intelligent way for us to build a smart building that is going to enable us to do all the things that we need to as a business to be competitive and et cetera, right?
Absolutely. You'll see the networks actually be part of the actual building design from the get-go, as you pointed out.
Yeah.
And so that we can enable all these experiences and outcomes for the occupants of spaces.
I love what this is doing because I love the fact too that you mentioned there's a GigE port essentially almost every 8 feet when you think about lighting drops.
Right.
And just think what, to those of us that are used to thinking in those technology terms, what does that enable? And there's already a bunch of good ideas from the partners that we work with, a lot of the innovation, because again, we're providing the network, the PoE and the power, but we're relying on others to bring the light as that first entry point into how we're going to make that happen. But I like where this is going. Wish I'd done this in the house I just built with that. Louis, is there anything else that we need to understand here before we go?
No, I think we've covered it, and I'm excited to bring this forward to the market.
You can leave this stuff here. You're going to take it back up to your lab.
No, it's coming back with me.
All right, well, I'll shake your hand anyway. Thank you so much, Louis.
Appreciate it. Thank you.
The light bulbs that we grew up on produce light through heat. LEDs, or light-emitting diodes, they convert electricity directly into light. That's a big part of why they're so efficient. Well, invisible or infrared LEDs have been in our remote controls since the 1960s. The first visible LEDs were low intensity and limited to just red. It took another 10 years to get green and then yellow. So yeah, we had red, green, yellow, which of course became traffic lights by the 1980s. The point is that LEDs have been around for years, but only in certain colors. The big missing color was blue. Once we had blue, we could mix it with red and green to create white. Well, Cree was founded in 1987, and they brought the first blue LED to market in 1989. Cree recognized that solving the blue brightness issue would be a critical first step to mass market adoption of LEDs. And they've continued to innovate as they push the quality and the efficiency of their lights. And once that 100 lumens per watt barrier was surpassed, the stage was set for us all to start moving to the digital ceiling.
The genesis of Cree is quite interesting. When we first came out with the LED and we started talking about replacing the bulb, we were replacing the last vacuum tube. The transistor came about and revolutionized computing. There was still this last vacuum tube out there. And so in all of your ceilings you had that, and there was nothing much you did with that other than replace it on a regular basis.
An LED is a semiconductor device that emits light. If you look at the other technologies, talk about an incandescent bulb. An incandescent bulb really is the filament that you heat up until it glows. If you look at a fluorescent product, it's very similar in terms of, in this case, you're heating up a gas. That gas puts off a light that then illuminates a phosphor element inside the tube. And both of those tend to be inefficient compared to an LED technology.
I actually knew some of the founders when I was getting my PhD at NC State. They were material scientists and a couple of business guys that had the concept that if you could make blue light, you could make white light, you could do a lot of things with it. As we improved the efficiencies and the powers and got brighter and brighter blue, then you could start talking about converting that to white. And then once you started getting to 100 lumens per watt, people started to say and believe that you could start to use this in white light. All of our intellectual property laden R&D is done on this site. This is our headquarters. We have about 1.5 million square feet of manufacturing space. We have teams working side by side with manufacturing style lines, 24/7. We're parallel to the production process, so we get real-time immediate feedback.
And that allows me to take that data then and look at productivity improvements for that space or enhanced user experiences. So one of the things that we do with our True White technology is the ability to add a yellowish white with a red, tune that on the black body curve and represent really a high quality light with the best color rendering index possible.
We actually have receptors in our eyes that recognize those different colors of light or different wavelengths. Artificial light essentially fools us into thinking it's daytime later than it is.
Severe Alzheimer's patients live in a world where, every minute is a new minute. So they don't recognize what time of day it is. They don't sleep well, they don't eat well because they just don't know what moment it is. And a lot of these patients will be housed in a typical traditional hospital where the fluorescent lighting is basically the same.
The circadian rhythms are essentially what regulate our body clock to let us know that it's time to go to sleep at night and time to wake up in the morning.
Well, they've now done studies where if you put in LED lighting with controls to mimic circadian rhythms or the time of day, their quality of life is drastically improved. It helps them sleep, it helps them eat. It opens up amazing possibilities where technology, again, meets people.
In the United States, approximately 20% of our electricity is used for lighting. In a commercial building, it's actually usually much higher than that.
As soon as you take out some of the wasted power that's being dumped into a room, it also improves some of the thermals and the HVAC management. So to get a LEED certification, you're trying to look not just at your energy consumption into your lights, but you're also trying to look at your energy consumption into your environmental. The minute you get controllability of that light beyond just on and off, dimming and occupancy and those types of things, you can add another 70% savings to just the lighting experience itself.
So that's really going to be the first step you're going to get out of these systems is that additional energy savings that you're not going to get over traditional LED products. The next phase is going to be really then leveraging that connectivity.
Any sensor or receptor that exists today can be put into the digital platform.
We can now economically deploy a high-powered digital device that has integrated sensors, processing, software, and networking essentially every 8 feet in a building. We don't see any other industry that has the ability to do that.
Light drives capability. The control of the light itself, it can be used to save you money, can provide health benefits, can provide educational benefits, can provide safety benefits. Solid-state lighting is the place where science and technology meet the human condition. It's the perfect interface.
Hey guys, one of the biggest values you could get out of this particular show is the workshop. We do a workshop with just about every one of them. You can look below the video to find a link, hopefully to the live version where you get a chance to interact with some of the same experts that we use on the show and cover the topic in much, much more detail. It's incredible value, and in case you missed one, you can always go to the archive at techwisetv.com, look them up there, and you won't want to miss it. It's good stuff. Check out the workshops, techwisetv.com. See you there. It is incredible what can now be done with lighting. I mean, how fast we are changing and yet how far we can actually go. Remember, lighting is just one part of the digital ceiling. We have so many components here: the LED fixtures, the intelligent driver, the sensors, the network infrastructure, lighting control system, the applications. But as amazing as all of this is, it's very familiar territory for most of us. All right. I also love the fact this does not require another layer of complexity and cost on top of a new infrastructure. It logically replaces some hefty expenses, so the payoff is not sometime in the future, but much closer to right now. It just makes sense. In fact, that's why I love history. This puts a modern twist on the AC-DC wars we talked about at the beginning from back in Edison's time. Remember, Edison had to design a network to get electricity to his longer-lasting light bulbs. He was very focused on that network being direct current. Well, the Achilles heel for DC was that it could not supply electricity for anything other than short distances. Well, industrialist George Westinghouse had developed a system that used a competing high-voltage alternating current. And he and Nikola Tesla, a former employee of Edison's, invented AC motors and generators that directly challenged Edison's domination of the electrical industry. And when the Niagara Falls contract for the first major hydroelectric power plant was awarded to Westinghouse Tesla, it became the deciding factor for Tesla's alternating current over Edison's direct current. Well, AC spread across the country, and it became what we're using now in our homes and our offices because it handles distance quite well. Well, now here we are in the digital age where every electronic component uses DC, despite the fact that we have an AC infrastructure. Low voltage direct current now plays an important role in the digital ceiling. The DC is just a coincidence. So maybe Edison didn't really lose that battle after all. Something to think about. The economics of LEDs are getting us started on this digitization journey, but it's the network connectivity that really sets us up for the future. And that future is right here with the digital ceiling. Guys, thank you so much for watching. This is so much fun. If you're still craving more details, I'm going to have a bunch of stuff up on the show notes with the blog. That's at blog.techwisetv.com. All of our information is scrolling across your screen. On Twitter, you can follow me for updates and insights. It's at Rob Boyd, 3 B's in a row. Follow the show itself at TechWiseTV. And all the shows, as always, can be found at techwisetv.com. Guys, thank you so much for watching. This was a lot of fun. We'll see you again next time.